I am very pleased to participate in the conference. My name is Monika Sijko. I am PhD student in the Warsaw University of Life Sciences. Today I will be talking about on the influence of dietary compounds on arsenic metabolism and toxicity. Many dietary compounds have a beneficial effect on the metabolism and toxicity of arsenic, but it seems that the strongest relationships are shown by the compounds involved in the metabolism of arsenic. As you can see, methyl donors, methionine, beta-in, choline, folic acid, and also cofactors of reactions vitamin B2, B6, B12, and zinc are involved in the one-carbon metabolism. These pathways produces S-adenosyl methionine, which is necessary for metabolism of arsenic. Metabolism of arsenic take place in the liver and involve the series of alternation reduction and methylation reactions during which inorganic arsenic is converted to mono and dimethyl arsenic acid, and in these forms is the most often excreted by the kidneys. Due to the limited amount of time, I will only present two selected dietary compounds which can be a potential modulator. The first is vitamin B12. It's a cofactor of reaction methylation. I will present the result of studies carried out with the individuals exposed to inorganic arsenic, mainly with drinking water. Regarding to vitamin B12 intake and arsenic metabolism, the beneficial effect was observed in the two studies. Vitamin B12 intake was positively associated with urinary percentage of DMA and negatively associated with percentage inorganic arsenic in the urine. Similar effect was observed in the studies in which analyzed vitamin B12 concentration in the blood. In these studies demonstrate positive correlation between vitamin B12 and percentage of DMA, and also negative correlation with urinary percentage of MMA and inorganic arsenic. In other studies, effect wasn't significant because many factors could have influenced the results. There is no detailed information in the studies of vitamin B12 intake in relation to the norms. Lack of association may arise from low variability of vitamin B12 intake, or that intake was above a sufficient level in this population. This issue requires future research. Let us now turn to the studies which analyzed the relationship between vitamin B12 intake and adverse health effects in individuals exposed to arsenic. Here are examples. In the two studies, not observed correlation between intake vitamin B12 and risk of skin lesions, and also between urinary total arsenic and achievement among children and B vitamin intake. A protective effect of vitamin B12 was demonstrated in one study, in which a reduction in the severity of oxidative stress was observed in adults who had a higher intake of B vitamins. On the other hand, a low intake of vitamin B12 was associated with worse cardiovascular outcomes. Regarding to plasma concentration of vitamin B12, low concentration of this vitamin was related to an increased childhood developmental delay. In the one of study demonstrate positive association between the plasma concentration of vitamin B12 and global levels of post-translational histone modification. The two studies didn't demonstrate relationship between the concentration of vitamin B12 in the blood and susceptibility to develop skin lesion, and also with type 2 diabetes. The second dietary compound is folate, which is a methyl donor. Let me start with arsenic metabolism. In these cases, folate intake was positively associated with urinary percentage of DMA and was negatively associated with urinary percentage of MMA and inorganic arsenic. Moreover, in 4 studies, analyzed the supplementation of folic acid in doses 400 or 800 micrograms per day for 12 weeks. Improved inorganic arsenic metabolism in adults, mainly through increased urinary percentage of DMA and decreased concentration total arsenic, as well as decreased percentage of inorganic arsenic in the urine or in the blood, were observed. Folate concentration in the blood also show a relationship with urinary arsenic metabolites. In the several studies, folate concentration in the blood was positively associated with urinary percentage of DMA and negatively associated with percentage of MMA and inorganic arsenic. Such a relationship between folate intake and urinary metabolites of arsenic wasn't confirmed in another studies. As vitamin B12, there was an underestimation of folate consumption in the studies, and this aspect requires future analysis. Nevertheless, supplementation with a certain amount of folic acid was associated with more efficient arsenic methylation. Next, I would like to look at studies which analyze the relationship between folate intake and arsenic-related health outcomes. In two studies, no relationship between folate intake and increased risk of diabetes, metabolic syndrome, and also with bladder cancer risk were observed. In turn, a low intake of folate was associated with worse cardiovascular outcomes and with increased risk of skin lesions. But in one of the studies showed that high intake level folate can decrease risk of skin lesions. Now moving on to look at studies regarding to folate concentration in the blood. In men with a low concentration of folate in the plasma, a positive association with increased DNA methylation was observed. In other studies were related to increased childhood development and delay and with increased risk of urothelial carcinoma. In the one of the study didn't demonstrate relationship between the concentration of folate in the blood and the susceptibility to develop skin lesions, but in another study, subjects with low plasma folate concentration had an increased risk of skin lesions. Interestingly, a higher odds ratio of type 1 diabetes was observed in individuals with a higher concentration of plasma folate. To sum up the results of human studies on the relationship between nutrient intake or the blood concentration and arsenic metabolism indicate that some nutrient may contribute to arsenic elimination from the body because correlated with urinary arsenic metabolites, but in the several studies this correlation suggests that these nutrients may or may not impair arsenic metabolism. The authors also observed a relationship between high intake or concentration of vitamin B12 and folate and reduction in the adverse changes associated with exposure to arsenic. In turn, low intake these dietary compounds were associated with health deterioration and also increased risk of disease. However, in several studies there are conflicting data that require clarification. Human studies to date are inconclusive because many factors influence the results. Factors which can influence our arsenic metabolism and which could have caused differences in the studies are age, sex, smoking, alcohol consumption, nutritional status, metabolic differences, and arsenic exposure level. This signals the need for a more detailed analysis of the relationship between the nutrient intake involved in arsenic metabolism, nutritional status, as well as source of arsenic exposure. In the end, I would like to stress the fact on nutritional education, focusing on adequate dietary intake of these nutrients which potentially have modulating effects in arsenic metabolism and toxicity should be used in the prevention efforts for a population exposed to inorganic arsenic. That brings me to the end of my presentation. I hope you are a little clearer on nutrient which can be a potential modulator of arsenic metabolism and toxicity. Thank you for your attention.